In 15, we want to find the vertical asymptotes and the horizontal asymptote. So the vertical occur when the denominator is 0. So for vertical asymptotes, we have x is equal to -5 and x is equal to 1. Now, for horizontal asymptotes, we take that those are determined by the end behavior. So we have our equation is equal to, if we just take the first term from the top and the bottom, x plus other things, and then the denominator x squared plus other things. So as x goes to infinity, we just look at x over x squared equal to 1 over x, and that goes to 0. And as x goes to minus infinity, we have the same situation. 1 over x goes to 0. So since this is a finite number, we do have a horizontal asymptote at y equals 0. And these are our vertical asymptotes. In 16, we're sketching a graph. So let's start by finding the x-intercepts from the numerator and the vertical asymptotes from the denominator. So here we have for the numerator, I'll factor out the 2. So we have x-intercept is x equals 3. And we have a vertical asymptote from the denominator, x equals 0. Let's look at the end behavior. So as x goes to infinity, we're looking at 2x over x squared, which is equal to 2 over x, which goes to 0. And we'll have the same thing on the other side. So y equals 0 is a horizontal asymptote. Now, y-intercept is none, because if we substitute in x equals 0, the denominator is 0, so no y-intercept. All right, let's look at our graph. Let's start over here. We're going to put in the x-intercept at 3. The end behavior, well, let's put in the vertical asymptote that x equals 0, so that's the same as the y-intercept. That's our vertical asymptote. And the end behavior is it's going to flatten out at y equals 0, so that would be flattening out over here, and on the left also. The vertical asymptote is going to go either up or down. We'll decide which arrow it is, up or down. Okay, let me put an open circle here. That's where the denominator is 0, or the vertical asymptote. Okay, now what we usually do is a plus-minus analysis, and we do that between the open and the closed circle. Okay, so on this side of the graph from here, we're breaking it up like this, and like this. So now we're looking at, this is 3, let's say when x is equal to 4, the top and the bottom are positive, so positive here. Let's substitute in 1, and we have negative over positive, so this is negative. And let's substitute in minus 1, and we have again negative over positive, so again negative. Okay, so now let's connect what we can. So we're going to, here the graph is positive, so I'm going to choose this top arrow. Okay, and we have to connect with this x-intercept, so let's do that like this, and then connect with this down arrow because the graph is negative here, so this is going to, I'm choosing the down, not the up, so we're just going to connect with that. Okay, so the graph goes down. Okay, on the other side the graph remains negative, so I'm going to use this down arrow and this one and just connect the two in a round way. And that's our graph. In 17a we have a quadratic inequality. Let's get 0 on the right hand side. Factor out the x. Now less than or equal to 0 means negative and 0. So now we do our plus minus analysis. On the number line, let's put the zeros of x times x minus 2, so that would be 0 coming from this factor and 2 coming from this factor. And then we'll do a plus minus analysis. So when x is bigger than 2, this is positive. Then it switches to negative, and then positive. And let's look at this. We want to choose where the expression is negative and 0. Okay, so here it's negative, and it's 0 at these 2 points. So we have everything between 0 and 2, and including 0 and 2. Okay, in B, again we want 0 on the right hand side, so let's subtract that 1. Now we want to combine these so that we have one fraction on the left. Common denominator is x plus 4. Okay, so here we have a denominator of x plus 4. 2x minus x, that's x. 2 subtract 4, that's negative 2. Okay, now we want to do a plus minus analysis of this quantity. Put the 0. Okay, here's, let's say this is x equal 2. Put a closed dot here. And then we have, for the denominator, we have negative 4, and that gets an open dot. Because it comes from the denominator, and x cannot be equal to negative 4, so an open dot there. If we do the plus minus analysis, we have positive, negative, positive. Let's go back to this. We're interested in when this is less than or equal to 0, or here it's the same. So that would be negative and 0. So here's negative, and here's 0. So we have the interval minus 4 gets a round because we don't want to include it, and 2 gets a square.